Welcome. We're going to talk about cars. We're going to talk about self-driving cars today. Last year, we introduced the Drive PX self-driving car computer, and I said three things. I said that in the future, when you build cars, it's going to be a lot more like a computer. That the ability for car companies and system OEMs to configure cars by connecting sensors and controllers one at a time and evolve it over time is going to be more and more difficult. That you have to approach it from a computing system perspective. Software is going to be a very big part of what you do, and ongoing improvements of the software is going to be very important. The second thing I said was that computer vision technology that had evolved up to this point using hand-coded features and engineers crafting pieces of code to detect objects in the world are going to be difficult to continue to advance to the point where we could have cars that drives itself. And that we would use a technology called deep learning. The third thing I said was that all of this computation capability is going to have to be done in real time. Because your car is driving through the streets, a lot of things are happening around the world, and you want to be able to detect it, understand what to do, and have the car keep you out of harm's way and navigate safely. So the third thing I said was we're going to need supercomputing technology. All of this we've been working on the last year, and today I'm going to give you an update on that. Several thousand man-years of effort have gone into advancing the state-of-the-art of self-driving cars at Nvidia this last year. So first of all, I'm going to tell you the punchline. Ladies and gentlemen, the Nvidia Drive PX2. This is the world's first in-car AI supercomputer, and it's designed to make it possible for us to realize the vision of self-driving cars. It has 12 CPU cores, 4 chips, each with Pascal GPUs in it, with a combined processing capability of 8 teraflops, with a special new set of instructions designed for deep learning that makes it possible for us to achieve 24 deep learning teraops per second. It's built with 16 nanometer FinFET. All together, this entire supercomputer fits in your trunk very nicely, the size of a lunchbox, 250 watts, all in that little tiny device. PX2 is equivalent to essentially 150 MacBook Pros. Imagine 150 MacBook Pros of processing capability in your trunk. All of this within the size of a school lunchbox, 250 watts. It needs to be water-cooled, and the reason why it needs to be water-cooled is because we want to be able to make it possible for you to have this operate in all kinds of severe conditions that a car could be enjoying. Okay, so NVIDIA Drive PX2.